All right. Well, I had some questions on Unit 9, Section 2 and 3. So this here is the worksheet for 2, and it's just a maze that they have created that can kind of give you some practice in simplifying radicals. And then this one here is just a checkpoint for the quiz. So quiz 1 is just kind of a review of simplifying radicals. So I'm going to go through a couple of these and show you how to simplify radicals. This one here, if you just want to pick and choose a few just to make sure you understand how to simplify a radical, go ahead. But you don't necessarily need to do all of these. All right, so I'm going to do number 2, the square root of 72. Now, there's two different ways that you can simplify a radical. You can simplify it by using the perfect square method, or you can simplify it using the birthday cake method. I will show you both, and you can decide which you prefer. In order to use the perfect square method, you need to know what your perfect squares are. So, for instance, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, and so on. And what you want to do is you want to find out which one of these perfect squares is 72 divisible by. Evenly divisible by means no remainder. And you kind of want to work your way backwards because you want to find the biggest perfect square. And sometimes what I do is I'll just grab my calculator, put it on this side so you can see it, and I'll just go ahead and start dividing. So I know it's not going to be divisible by 100 or 81 or not even 64, but let's see if it's divisible by 49. So 72 divided by 49, I get 1.46. So nope, not 49. Let's see if it's divisible by 36. 72 divided by 36. Oh, yes, I get 2. So I know that 36 times 2 equals 72. So now I'm going to write the square root of 72 as the square root of 36 times the square root of 2. I always tend to put the perfect square first. So I'm going to put this one here, the 36 first. Well, we know the square root of 36 is 6 because we know 6 times 6 is 36. And the square root of 2 I can't simplify. So now we know that the square root of 72 can be simplified down to 6 times the square root of 2. That's the perfect square method. Another method you can use is called the birthday cake method. And in using the birthday cake method, you need to know your kind of the low prime numbers. So you're going to use prime numbers 2, 3, 5, 7, 11, maybe more, but probably mostly those. And what you're going to do is you're going to keep dividing this number by the lowest prime number you can. So this one works up, so I'm going to start down here. 72. Well, I know 72 is even, so I know it's divisible by 2. So I'm going to divide it by 2. 72 divided by 2 is 36. Well, 36 is divisible by 2, so I'm going to keep going. 36 divided by 2 is 18. Well, 18 is even, so that's divisible by 2, so I'm going to divide it again by 2. I get 9. Well, 9 is not divisible by 2, so now I'm going to go to the next one, 3. Well, 9 is divisible by 3, so I'm going to divide it by 3. Well, 3 is not divisible by 2, but it is divisible by 3, so I'm going to divide it by 3. And you know you're done when you have a 1 on top. They call this the birthday cake method because it kind of looks like a big birthday cake with the candle on the top. What you do now is you circle anything that you have 2 of. Well, I have 2 2s, but I don't have a match for this 2, so I can't circle him. And I have 2 3s. So anything that's circled will come outside of the radical and you'll write it just once. So I have a group of 2s and a group of 3s, so they can come outside of the radical. But this number 2 here, he doesn't have any friends, so he has to stay inside. He can't come out and play until he has friends. So now 2 times 3 is 6, so this is 6 times the square root of 2. So you can see we get the same answer regardless of which way we do it. It's just a matter of personal preference and which you like better. I'd like to show you one more example. Here, if you take a look at number 5 and 6, now they have a number out in front. So it's like -4 times the square root of 16 or -7 times the square root of 28. I'm going to do this one here for you. Negative 7 times the square root of 28. Well, 28 is a pretty easy one to do using the perfect square method because I know 7 times 4 is 28. So I'm going to write this as negative 7 times the square root of 4 times the square root of 7 because 4 times 7 is 28. Well, I know the square root of 4 is 2. So I'm going to evaluate that as 2. Once I'm evaluating that square root, I can get the square root symbol away because the square root of 4 is 2. It's not the square root of 2, it's simply 2. And I'm just going to bring this negative 7 down and this square root of 7 down. Well, now I can multiply these. Negative 7 times 2 is a negative 14. So this would simplify down to this. Negative 14 times the square root of 7. If you have any more questions on that, let me know.